Hello on the planet and beyond. I am Sade, the founder of Between Here and There, a Thrive based consulting business surrounding global hygiene and applications of information technology. We define global hygiene as the cleanliness and the health of the planet. And on today, I want to get into our map reading series. And so, starting off, we're going to get into what is latitude and longitude and get some global positioning as to where you are in the world. Okay. So it is on 2023 0808 at 1100 here on the east coast of the United States. And let's get started. Okay. So when it comes to map reading, we understand the globe to we understand the planet to be the shape of a globe, okay? So a round sphere type of shape. And from that shape, we need to create these 3D models in which we can develop into a digital model by applying other layers, or we can keep it as a physical layer. So the old, what they say, the old school maps, okay? So a physical map. And when you use this information with technology, you're able to build upon it and create these models that go into other dimensions and be able to use those, as you've probably seen from other type of map applications. When you click on what would be seen as like a digital map, you're able to maximize and minimize the image and be able to get deeper into that image to identify different um, items in another dimension. Okay, so now you have these figures in which you're able to maneuver. You're able to look at buildings. You're able to look inside the buildings, roads, waterways, highways, etc. So with that, there's these different projections. So you have a Mercator projection. You have a pyramidal. So these are basically taking the globe shape, the sphere, and creating a model that is able to lie flat, okay, as possible. And I believe I have one moment. Some of my tools. So, to be able to take a sphere shape, for our blue planet, which we got a bunch of cleaning up to do, these our waterways, our airways, etc. But the sphere shape, to be able to create a shape that is flat like this. And there's different models that people have used to create that shape. And those are projections. That is the visual representation of what a sphere would be. Okay, so it's a flat. From there, the globe is divided into a latitude and longitude. So with longitude, I always think long because that is the first four letters of longitude. Long. Okay. Itudie. And latitude. Okay. And so latitude is a horizontal spacing of the globe. Okay. So, and within those, they're divided into degrees, and the degrees are used to co-locate a specific point on a map. Okay, so using the crosshair or the intersection of longitude and latitude, you're able to identify a specific point on the globe. And there's differences in the latitude and longitude, and we're going to get into those specifics, starting with latitude. Okay. So latitude is your east to west direction. And that starts, let's see if we can We're gonna work with what we got, okay? And so it starts at the equator at a 0 degree. That is here. So the equator is running across here from Gabon, Congo, Kenya, and it's going over, passing through Indonesia, North Pacific, and going across the top of South America. Okay. From there, it's positioned from north to south. Your north direction, you're going from 0 degrees at the equator and you're going up to 90 degrees. Okay, so each section is normally on a map like this, just divided into each 10th degree. So 10, 20, 30, 40, 50, 60, 70, 80, and 90 degree being at the very top. Okay, and so at the very top you have your Arctic, and at the very bottom you have the Antarctic. Okay, so the opposite, going from the south, it will be from 0 degrees at the equator, 10 degrees, 10, 20, and it's going in the south direction. Some people, I've noticed, when they're trying to identify a point on the map, they might put a negative there just to show that that's down versus putting south. So it kind of depends sometimes when people record this information and for what reason they're using it for. It could be listed as north and south or positive versus negative. So yeah, so from there it can be further divided. Okay, so that first number, so say we're going to go to 30 degrees north. Okay, from the 30 degree in between the 40 degrees, it is subsequent degrees. So 31, 32, 33. So from there, you're able to divide this further. So like a fraction. Okay, so a fraction of that specific point on the map, and you're able to pinpoint, because this is a lot of land being covered. Even though a map is a projection, it's it's a vast amount of land being covered and displayed on a map. So to get a more accurate and specified coordinate will allow you to get to the specifics of that place, location on the map. Okay, so you want to get as specific as possible, because just within identifying like Nigeria here on the map, it's between, so it starts at about around about 15 degrees is no, excuse me, I take that back, around 5 degrees going into about 15 degrees. Okay, and there's a lot of land covered there, so it's even divided into hectares, and that is a multiple of acres. I want to say, I need to get the exact number because I don't like to just give you information without getting those specifics. So how much of a hectare is covered in, how many acres are covered in a hectare, because a hectare is a larger quantity. So yeah, so it ended up being that, what we said, like 33 degrees. Okay, 45 degrees. So the 5 is getting you within the 40 and 50 degree block grid square, and it's getting you more specifically to that location. Then you have your longitude. Now, your longitude is a little different because it runs up and down. It runs up and down the map. However, when you are taking its point and you're getting your longitude, it runs from east to west. Okay, So these lines are coming down from the top here, and it's a slight curvature because it is a spherical shape. Which let's go back to the sphere. The latitude is running across this way. So your equator, right half of the sphere, you're going up 90 degrees, going down 90 degrees. However, your longitude is running from the very top or bottom and going down to the very top or bottom. So it's slightly curved because our globe is a curvature. Okay. So your longitude runs from 180 degrees around, well, covering 360 because of the sphere, right? It covers 360. However, it is from its starting point, which is in Geneva, which let me find it. I wonder why. That's really interesting. I would think on each map they would specifically identify, excuse me, Greenwich time. I said Geneva, like Geneva Convention, which it all surrounds each other, which we'll get in further into our studies. It all connects. However, Greenwich time, because it goes through Greenwich, England, okay? And so you'll see at the very top at your 0 degree mark, similar to the equator, but this is longitude, your 0 degree coming down as your starting point, okay? And I thought on this map it would identify because it is a very special location on the planet. But it didn't have anything to specifically denote Greenwich, which is interesting. So, learn something new every day, right? So, starting at 0, when you're going to the east, you are increasing your degree. When you go into the west, you're increasing your degree from that 0 degree starting point. And this also gets into your time zones, which I'll have a separate course for that. Not necessarily a course. I would say these like informative sessions because the courses are actually, it's more detailed. There are more takeaways. This is information that you can use and apply. The courses is information for it to be in more digestible pieces, how you can use it, when to use it, when not to use it, as well as some other tools that we give you within the course that you can take throughout your journey. So, yes, these longitude is covered from 0 to 180 around the globe. And also, it is different. The spacing is different. The distance in between each longitude degree is different from latitude. So with latitude, everywhere it's exactly the same. And 1 degree is about 69 miles. 1 minute, which I'll make a separate session to go into because this video is about to end. 1 minute is 1.5 miles, and 1 second is 101 feet. Okay, so that's it for latitude and longitude. I'm going to go into more information on longitude and go into the second session of map reading. So thank you for joining me today, and I'll see you for the second one.